Welcome to Let's Learn by NSK YouTube channel, Mainframe Interview Questions. Today we are going to tackle a very common topic that frequently appears in mainframe interviews: the distinction between temporary storage queues, or TSQ, and transient data queues, or TDQ, within the CICS environment. Understanding these two concepts is fundamental for any aspiring CICS developer. Both TSQ and TDQ are methods used by CICS applications to store data temporarily. Think of them as scratch pads or temporary holding areas where a program can place information for later use, either by itself or by another program. They are essential tools for managing data flow and state between different transaction executions. At any point in this video, if you feel this video is helpful, please like this video. So, what exactly is a temporary storage queue, or TSQ? A TSQ is a facility that allows an application program to store data in a queue that can be accessed later. The data is stored under a specific name, which can be up to 16 characters long. This name is how programs identify and retrieve the data. Each item in the queue is assigned a number, allowing for sequential access and direct access. On the other hand, we have the transient data queue, or TDQ. A TDQ is also a mechanism for storing data, but its primary purpose is different. The data is meant for temporary sequential processing. Unlike a TSQ, you cannot randomly access an item in the middle of a TDQ. You can only read items in the same order they were written, much like a first-in, first-out conveyor belt, and once read, an item is typically gone for good, ideal for logging, batch collection, or printing. Let's look more closely at the uses of a temporary storage queue. One common application: pass large amounts of data between programs. If a program gathers lots of user data on screen and must pass it to a second program for processing, comma may be too small. A TSQ is an excellent alternative. First program writes all data to a uniquely named TSQ. Second program reads from that same queue to retrieve it, overcoming size limits. TSQs also manage pseudo-conversational transactions. In CICS, a transaction typically ends after sending a map to the terminal. To keep context when the user starts the next transaction, the app must save state. A TSQ is perfect for that. Program writes working storage to a TSQ before terminating. When the user responds, the new transaction reads the TSQ to restore state, making the experience seamless. TSQs make great scratch pads. Imagine a user building a shopping cart or a list of items to process. TSQ acts as that scratch pad. As the user adds an item, the program writes a record to the queue. App can display the queue contents, allow modifying items by item number, or delete items. TSQ supports random read, write, and rewrite operations. Finally, TSQs help stage data for batch processing or reporting. An online CICS program can collect data during the day and store it in a TSQ. At day's end, a batch-style CICS transaction can read all records, perform final processing, or generate a report. This stages data in CICS before committing to permanent storage. A TSQ provides a highly versatile, randomly accessible storage area that is perfect for complex application logic and passing structured data between different transaction steps. Now, let's shift our focus to transient data queues and their specific uses. The primary function of a TDQ is to handle sequential data streams. A classic use case is for logging and auditing purposes. An application can write error messages, transaction logs, audit trail information. Since the data is written and read sequential, it creates a chronological record of events. This queue can then be directed to a file or another destination. It can be reviewed later by support staff or system administrators to diagnose problems or track activity. TDQs are also used to trigger other tasks automatically within CICS. This uses a special TDQ called an intrapartition TDQ. You can define a trigger level, simply a number of records, and when reached, CICS can automatically initiate a specified transaction to process the data. For example, collect print requests, and once 10 requests are collected, a printing transaction is automatically started. To understand TDQs fully, we must discuss their different types. The first and most common is the intrapartition TDQ. It exists only within the CICS region, where it was created and is used for communication between tasks inside that region. They support automatic task initiation, or ATI, via a trigger level, making them powerful for asynchronous workflows. The data in an intrapartition TDQ can be made recoverable, so if the system or transaction fails, the data will be preserved and restored upon restart. The second major type is the extrapartition TDQ. These are used to communicate with systems outside the CICS region. They are datasets defined to CICS that can be an input source or an output destination, such as a file, a printer, or another external device. Unlike intrapartition queues, they do not support trigger levels, and the data is not typically recoverable through CICS backout mechanisms because they represent external files. Let's summarize the main differences between TSQ and TDQ, which is a crucial part of any mainframe interview. The most significant difference lies in how data is accessed. A TSQ allows for random access, read, write, rewrite any item by number, like picking a specific record. A TDQ is strictly sequential FIFO. Once an item is read, it is consumed. Also, please like, share, and subscribe. Let's Learn by NSK YouTube.